Hey everyone, it's Jose here, and welcome to the course overview lecture. I'm super excited that you're starting your journey to learn Python. I know it's sometimes tempting to just skip these intro lectures and go straight to the technical material, but I have one favor to ask of you as you go through this course, and that is to please don't skip this lecture. We're going to cover a lot of important material in this lecture, such as where to find the notebooks, how to approach the course, how to ask questions, so please watch this entire lecture, that way you can get the best course taking experience possible. Alright, let's not waste any more of your time, and let's get started. In this lecture, we're going to talk about useful tips for going through the course, how to get help during the course, general advice on how to approach the course, where to find the course notebooks, and how to use the student chat channel. So some general tips as far as your course taking experience. When you're using the video player, you can use the gear setting to either speed up or slow down videos. So if you're like me and you like watching videos a little faster, maybe on 2x speed, you can use the gear setting for that. Or maybe English isn't your first language, you can slow down the videos, and you can also do things like turn on closed captions, or you can also change the streaming quality. You can use the Udemy app to download videos of the course lectures, and for more information on the Udemy app, you can check out the Udemy support pages for it. Also, make sure to use the Q&A forums. There's lots of previous discussion available there to help answer any questions you may have. Let's talk about getting help in a little more detail. Let's talk about the best series of steps to take when you have a question that arises while you're taking the course. If you're coding along with the videos, it's sometimes really easy to make a typo, which is why we provide course notebooks with explanatory text and the Python code for every single lecture. So if you ever get an error due to code that you thought you were following along with in the video, you should double check your code against our course notebooks. You can always just download the notebooks directly and run the notebooks, or copy and paste from the notebooks themselves. That way, you can make sure that your error isn't due to some typo while you're watching the video. Now, not every single question is going to be directly related to following along with our code, and if you do have a question, sometimes a quick Google search or a Stack Overflow search will get you the answer faster than anyone else could. So I would always recommend doing a Google search or Stack Overflow search, especially if you actually end up getting an error code in Python with maybe some of your own code that you were trying out. Just copy and paste that error code into Google, and a lot of times the very first hit is going to answer your question. Now let's say that still doesn't help you. What you should do is search our Q&A forums in the course. We've had over 250,000 students go through this course, so you can almost imagine that any question possible has already been asked and answered by either myself or our teaching assistants. So you should definitely search the Q&A forums before posting there. Now let's say you have a question on just general course things like how to get a certification or where the Udemy app is. Those kind of things are answered in our FAQ lecture. So we have an article lecture with frequently asked questions that you can check out for useful links and more information. Let's say you did all those steps and you're still confused on something. That's absolutely no problem. We're here to help you. The way to do that is to submit a new question to the QA forums and make sure you provide details on what you've tried, screenshots of your error code, and really as much detail as possible. That way we can help you as quickly as possible. Now let's say you have some sort of platform level issue. For those kind of things, you should email support@udemy.com or go to the Udemy support page and open a new issue there. So platform level issues are things like having video playback issues, questions or issues with your certification, or questions or issues with payments. Those are platform level issues and we can't really help you out. So email support@udemy.com to quickly get help on that. Finally, let's talk about how to approach the course. The best way to approach the course is to really review the notebooks along with the video. The videos are really great, but we want you to leverage the power of the notebooks we have for you. And both beginners and experienced users can really use the notebooks to best suit them. For beginners, I would recommend that you read the extra notes in the notebook as you go along with the video guide. If you're more experienced, what you may want to use notebooks for is to quickly review them and see which parts you may already know or may already quickly feel comfortable with. That way you don't feel slowed down by the videos. So beginners, really use the notebooks, read them well, go along with the video. Experienced users, check out the notebooks first and see if you really need the video. Or it allows you to maybe skip certain parts of the video and go to where you need a little more drilling down in. As far as these course notebooks that we keep mentioning, you should check your automated welcome message for the link to the notebooks. Later on, we're going to review how to actually download and open them in the Running Python Code lecture. These notebooks are actually a special file type meaning when you download them, you're not able to just double click them and have them open. We discuss in a lot more detail throughout the course on how to actually open these notebooks that you've downloaded. The notebooks are hosted on GitHub though, so you'll be able to view them at any time, even without downloading them. The link to download them is also in our FAQ lecture. So either check your welcome message or go to the FAQ lecture for that link. Now let's talk about the student chat channel. There's also a link for our student chat channel in the automated welcome message to join our Discord server. This is a chat channel that's shared between all our courses, so you'll be able to interact with students learning about data science, finance, SQL, R, Scala, and more. In the automated welcome message, there's also a link to a YouTube video describing further information on how to use and log into our chat server. It's actually super easy, but we have that YouTube video in case there's any confusion. Something to keep in mind is that the purpose of that chat channel is to connect students with other students. Technical questions related to the course material are still best suited for our question and answer forums. So you should use that chat channel to have fun, engage with other students, but if you're having a problem with a lecture or a topic or concept in the actual course, those questions are best suited for the question and answer forums. And remember, you can always search the question and answer forums for previously posted questions. Hello, and welcome to the Course Curriculum Overview. In this video, we're going to be getting a brief overview of all the content in this course. Let's go ahead and get started. First, this course starts off with an introduction section, including this overview, a discussion on Python 2 versus Python 3, and a lecture on how best to approach this course to maximize your benefits from taking this course. After that, we'll get started with a Python setup section. We'll learn how to install Python on your computer. We'll learn about environment selection. We'll learn about the Jupyter Notebook system. You'll get access to additional learning resources online, and then we'll have a brief overview on Git and GitHub. Next, we start with the live code sections. We'll learn about object and data structure basics, including numbers, strings, lists, dictionaries, tuples, files, sets, and booleans, all in Python. After each of these individual lectures, there's quizzes to test your understanding. And at the end of this section, there's an assessment test, so you can check your knowledge on each of these topics. Afterwards, we'll get a section on comparison operators. We'll learn about both basic operators and chain comparison operators, with this section ending with a quiz to also test your understanding. Then we'll move on to Python statements, including if statements, for loops, while loops, the range function, and list comprehensions, all in Python, with an assessment test at the end to test your understanding. Next, we'll learn about methods and functions, what they are, how to create them. We'll also learn about lambda expressions, nested statements in Python, and scope in Python. We'll top it off with a homework assignment to test your understanding about methods and functions. Then, you'll have your first milestone project, where you will create a game with Python. Then, we'll move on to object-oriented programming, where we'll learn about objects, classes, methods, inheritance, and special methods, all in Python. Then you'll get a homework assignment to test your understanding. After that, we'll learn about errors and exception handling in Python, including what errors are, what exceptions are, and how to use try, except, and finally to handle errors and exceptions. Then, we'll top it off with a test to test your knowledge and your understanding so far in the course. Then, you'll come up with your second milestone project, where you're going to create a more complex game, all in Python. Afterwards, we'll learn about modules and packages in Python, how to create them, how to install them from the internet, and we'll explore the Python ecosystem in general. Then we'll move on to built-in functions in Python, such as map, reduce, filter, zip, enumerate, all and any, and even how to deal with complex numbers. At the end of this section, we'll have a final assessment test where you can test your understanding for built-in functions. Next, we'll learn about decorators in Python, a 3-part series ending with a homework assignment. Afterwards, we'll learn about Python generators, including iteration versus generation discussions, how to create generators, and a homework assignment, again, to test your knowledge about Python generators. After that, we'll put together everything you've learned in a final capstone project. But that's not all. There's advanced bonus content, including an entire section about advanced Python modules and advanced Python objects and data structures, so you can level up your knowledge. There's new content regularly added to this section, with dozens of lectures. You'll also get access to community forums and a dedicated help from me, your instructor. So, that's the entire course curriculum overview, so let's go ahead and get started with the course. Thank you, and I'll see you at the next lecture. Welcome back, everyone, to this Python overview lecture. In this lecture, I'm going to do a brief overview of what Python is and a little bit of its history, why you may want to choose Python for programming, and what you can do with Python. And this lecture in particular is really geared towards people who are new to programming and Python is their first language. As a beginner, it's often unclear what you can actually do with Python and what the difference between base Python is versus lots of additional libraries. So hopefully this lecture can clear that up for you. Let's start with just a very brief history of Python. It was created in 1990 by Guido van Rossum, who is pictured here, and Python 3 was released in 2008, with subsequent releases happening after that, such as 3.1, 3.2, and so on. Now, Python, when developed by Guido van Rossum, was specifically designed as an easy-to-use language, with a very high focus on readability of code. And these are just a few of the things that have really allowed Python to explode in popularity. Readability and ease of use was something that was set ever since the start of the creation of the language. So why would you want to choose Python? As I mentioned, ever since the beginning, Python was designed for clear, logical code that is easy to read and easy to learn. Lots of other programming languages use braces and brackets that can make code convoluted and maybe hard to read. But Python makes use of something called whitespace and indentation that we'll learn about later on in this course that makes its code very accessible. Even if you don't know Python but you know another programming language, you can usually read Python without knowing the real syntax behind it. That's how readable it is. Now, lots of existing libraries and frameworks are already written in Python as well, allowing users to apply Python to a wide variety of tasks. Another reason that Python has really become popular in recent years. Another reason to choose Python is it really focuses on optimizing developer time rather than a computer's processing time. Usually, a developer's time is much more valuable as a person rather than just the computational processing time. So the whole language of Python is designed for users to really get prototyping up and running very quickly. It also has fantastic documentation online and lots of helpful resources if you just Google Python help. So the official documentation is fantastic, and you can check it out at docs.python.org/3. Okay, so what can you actually do with Python? This course really first focuses on what I'm going to call base Python, which consists of the core components of the language and writing scripts and small programs. Python is often referred to as a program that comes with, quote, batteries included, which means even the base version of Python actually comes in with lots of additional modules that you can use for writing scripts. And as an example of that could be something like the random module that comes with Python, which allows you to quickly create random numbers, or the math module of Python, etc. Now, once we learn about base Python and its base modules, what we can do is later learn about outside libraries and frameworks that greatly expand Python capabilities. These are frameworks that are not included with base Python, but you can easily download and then work with your basic Python skills. So what can you do once you start using those outside libraries? Well, a really useful part of Python, especially if you're someone who works in an office or as an analyst, is automating simple tasks. You can do things like have Python automatically search for files and then edit them, scrape information from a website automatically. It can read and write Excel files, work with PDFs. It can even automate emails and text messages and fill out forms for you. Python is also extremely popular in the data science and machine learning world. It can do things like analyze large data files using libraries like NumPy and Pandas. It can also create visualizations using outside libraries like Seaborn and Matplotlib. There's also machine learning tasks, and there can create and run predictive algorithms using outside libraries like scikit-learn and TensorFlow. So lots of outside libraries have actually been developed for data science and machine learning, and Python is the most popular language in that field. Now you can also create websites. So if you're interested in web development, people have developed web frameworks such as Django and Flask to handle the back end of a website and user data that can communicate with the front end of a website. You can also do things like create interactive dashboards for users using Python libraries like Plotly and Dash. So once you begin to understand base Python in this course and begin working with a few libraries, I think you'll quickly begin to see the vast potential Python has for you in your own projects. So keep in mind, this course really starts from the basics in base Python, and then as you get more and more skilled, we'll begin to introduce these outside libraries to perform tasks such as working with PDFs or web scraping sites. So let's go ahead and get started with setting you up for the course. Thanks, and I'll see you at the next lecture. Hey everyone, welcome to this crash course lecture on using your command line. Before we install anything, including Python, it's actually really important to have a very quick overview of how to work at your command line. And the command line basically allows you to programmatically move through your computer's directories. That way, you can run Python scripts at your command line. What we're going to cover in this short lecture is how to find your current directory, how to list all the files in a directory, how to change a directory, and then how to clear the command line screen. Something you need to understand though is that the commands are going to be slightly different depending on what your operating system is. So for macOS and Linux users, go ahead and jump to this time in the video in order to go through your set of instructions. If you're a Windows user, go ahead and jump to this time stamp at the video to jump to your specific instructions. And then once you've gone through your command line crash course, go ahead and move on to the next lecture. Again, this is just because the commands are slightly different for Linux and macOS users versus Windows users. Okay, go ahead and jump to the correct timestamp and we'll meet back there. Alright, so let's go over the Windows command line operations. At your computer, to find the command prompt, all you need to do is search for the term CMD, and you should be able to find command prompt as the best match. If command prompt doesn't show up when you search CMD, instead just search for the whole phrase, command prompt, and then you should see command prompt desktop app. Once you've opened up your command prompt, you should see something that looks like this. Let's start off by finding out where are we currently located. Basically, what's our current directory? I can use the command line to interact with my computer, but to actually perform those interactions, I need to know where I'm at on my computer. You can think of this as basically programmatically moving around through files and folders on your computer. You can type out CD, hit enter, and this will report back your current directory. Now you'll notice the command prompt actually basically gives you the file path of where you already are, but sometimes if the file path is really long or you're dealing with more complex things like virtual environments or installations, it's always a good idea to check your current directory by typing CD. Sometimes things like the Anaconda prompt will have other directories in parentheses. You can always confirm your current directory by typing out CD, hit enter, and that reports back where you are. So I can see right now I'm under this particular user's folder. If I wanted to figure out what all the files and folders located in my current directory were or are, I can type dir, hit enter, and that reports back the contents of my directory. I can see here that there's the desktop, documents, downloads, as well as some hidden files denoted by starting with a dot. But basically, this is everything that's in this folder, C users Marcial. I can scroll down, see CSV files, pictures. Now let's imagine I wanted to actually move into one of these subfolders. What I can do is type CD and then the name of that folder. For example, if I wanted to change directories to my desktop location, I can type CD, change directory, space, and then desktop, hit enter, and now I'm at my desktop, and I can type CD to confirm that I'm at my desktop. If I want to go back up a directory, all I need to do is type CD, space, dot, dot, or period, period, hit enter, and now I've moved back up a directory. Now you don't actually need to type in the entire file path if you're moving around. What you can do is say CD, begin typing, such as the letter D, then hit tab, and you should be able to see it autocomplete for you. So as I hit tab, I get the various options of everything that starts with a capital D. So I can go to Documents, hit Enter, and then if I wanted to see all my documents, I can type dir, and we can see all our documents here. Again, if I want to go back, CD, space, dot, dot, And if I ever want to clear my entire command line screen, I can type CLS, and I've cleared the entire screen. All right, that's really all the basics we need to know for right now. Just to review, CD for current directory, dir to list everything in my directory, CD and then the name of the folder that I want to jump to. For example, if I want to go to downloads, CD downloads. Again, you can hit tab to autocomplete. And if we ever want to jump back up, CD ... And if we ever want to clear the screen, it's CLS. That's the basics you need to know. We'll see you at the next lesson where we discuss how to install Python. All right, so let's go over the macOS and Linux command line operations. And your command line in macOS and Linux is known as a terminal. So these commands work on both of these operating systems the exact same way. Let's get started. To begin working with the command line on a Linux or macOS, you first need to open up your terminal. Search your computer for terminal, either on macOS or Linux, it's called the same thing, and then open up your terminal. You should eventually get something that looks like this. The colors or font may be slightly different, but the basic idea is the same. The terminal gives you a command line interface, and the command line interface allows you to move around different files or folders on your computer. And with some more advanced functionality, you can also make new directories or remove directories. We don't really need to know that right now. All we really need to know is how to understand what our current working directory is, change directories, and just move around. This basically allows us to move around the computer at the command line. The first thing we want to know is where we're currently located. To know that, type pwd, hit enter, and this will print your working directory. This is where you're currently located at the command line. If you want to understand what files and folders are located at your current location, type ls and then hit enter, and you should see a list of different files and folders at your current directory. If you ever want to move to one of those files or folders, what you can do is type cd and then whichever file or folder you want to go to. However, it should be in the list that was just printed. For example, let's move to our desktop. So I will come back down here and type cd desktop, hit enter, and now if I type pwd and I hit enter again, I'm now at my desktop. If you ever want to clear your screen, just type clear, hit enter, and now you've been able to clear your command line. If you ever want to go back up a directory, it's just cd space ... hit enter, and now we're back up a directory, which I can confirm by typing pwd. That's really all we need to know as far as the commands are concerned. Let's have a quick review. To print your working directory, it's pwd, and this reports back where you're currently located. If you want to know the files and folders at your current location, type ls, and this will list all the files and folders. If you want to clear your command screen, type clear, hit enter, and this will clear your command line. If you want to change directory to a subfolder, type cd, and then you can even begin typing the name, such as desktop. And if I just hit desk and then hit tab, it should autocomplete. If you do not get an autocomplete by hitting tab, that's probably a good indicator that it's not a direct subfolder of your current directory. But then you can type cd, the name of the subfolder or subdirectory, and then we can see now we're located here by typing pwd. If you ever want to go back up, type cd space ... Okay, that's the basics of moving around through the command line. We're going to be using that later on when we run Python scripts at the command line. We'll see you at the next lesson where we discuss how to actually install Python onto your computer. Welcome back, everyone. In this lecture, we're going to briefly discuss Python and its advantages in an overview, and then we'll show you how to install Python onto your computer. Now, Python was developed in 1991 by Guido van Rossum, and it's quickly become one of the most popular programming languages in the world. And this is because it has many advantages. The main advantages that Python has is that developers can learn it quickly, and this is because it typically involves a lot less code than other languages, and the syntax is a lot easier to read. And this is because, as you'll learn later on, is that Python makes use of white space. That is, it uses indentation instead of curly braces, and that allows users to really learn it a lot faster than they would other programming languages. And because of that, Python's now utilized by pretty much every major technology company in some capacity. And what's also really nice about Python is that there's a huge amount of additional open source libraries. Then that's basically to say, if you want to perform a particular task in Python, maybe you want to create PDFs in Python, send an email in Python, work with images, do data analysis, create a website, there's additional frameworks and libraries available to you that are open source that people have created that allow you to do those things. Python itself has a lot of stuff built in. It's known as a programming language that has batteries included, and that's because there's a lot of standard libraries that are included in Python that allow you to already do a lot of stuff. That is to say, for instance, it has a math library that has a lot of capability, but there are additional libraries in case you need to focus more on a particular niche topic, such as numerical computing. There's a library called NumPy for that. So to actually look at all these advantages and start learning Python, we need to install it. And we're going to install Python using the free Anaconda distribution. And the reason for that is that this distribution includes Python as well as many other useful libraries, including Jupyter, which is the notebook system we're going to be using throughout a lot of the course. Later on, we'll use things like text editors to write Python scripts, but when we first start learning, Jupyter is a great choice. Now, Anaconda, another reason we choose it is that it can be easily installed onto any major operating system, such as Windows, macOS, or Linux. One thing I do want to point out before we jump to the actual Anaconda download website is that because Anaconda includes a lot of these other libraries, there's also a miniature version of Anaconda, which is Miniconda, which is a lot smaller. So in case you don't have enough room on your computer for the full Anaconda installation, there's also Miniconda, and we'll be showing you how to work with that right after we show you the main Anaconda setup. So it is recommended that you use the full Anaconda, but just in case you don't have a fast internet connection or you don't have enough space on your computer, you can always use Miniconda. So let's begin the installation process by going to www.anaconda.com/downloads. I'll see you there. So at anaconda.com/download, the website will look something similar to this. It may be updated from time to time as far as the look and feel, but in general, it will have the download links for the various installers for the Windows, macOS, and Linux systems. And if you click on one of these, you'll be brought down to the actual download links for the graphical installers or the command line installers. By the time you view this page, it's most likely that 3.7 or 3.8 or even 3.9 has been released, so keep that in mind. Any version of Python 3 should be fine for our use cases. Now, if you're on Windows, you'll go ahead and download the graphical installer, 64-bit or 32-bit, depending on your computer. Most newer computers are going to be 64-bit. And if you have any questions on that, you can click to learn more. But basically, this is just a graphical installer. It's a wizard that's going to walk you step by step on the installation process. So for Windows users, click on this graphical installer, download it. If you're on Mac OS, click on this graphical installer and download it. And then if you're on Linux, you'll be clicking on this installer and downloading it. Keep in mind that Linux users have a command line installer, and you'll have to type commands that we'll show you in just a second. Once you've decided which version you're going to download, scroll down a little bit and click here where it says how to install Anaconda. And depending on what operating system you're currently on, it will take you to one of these three pages. Here you can see installing on Windows, and it has step-by-step instructions for installing. The graphical installers are really quite straightforward. You just select the defaults, hit next, and follow along with these step-by-step instructions. You don't need to worry about number 2 as far as verifying the data integrity. If you're on Mac OS, it's basically the same thing. If you click on that link on how to install, it will guide you through the graphical installation process for Mac OS. Again, step-by-step process, pretty straightforward. Just hit continue on all the screens. If you're on Linux, it's going to be slightly different. What you need to do is you'll be downloading a .sh file, and then at your command line or terminal, you'll be running this following command: bash, and then right here, downloads, Anaconda 3, and then whatever version you happen to be clicking on. Basically just copy and paste this command into your terminal. A quick note for Windows users, and this is a pretty important one. You'll eventually have a screen that looks like this, saying Advanced Installation Options, and you can choose whether or not you want to add Anaconda to your path environment variable. Anaconda themselves recommends to not add Anaconda as a path environment variable, since this can interfere with other software. Typically, what it's going to interfere with is previous downloads of Python. However, since this is probably your first download of Python, we actually highly recommend that you do add Anaconda to your path environment variable. This will allow you to call Conda-specific commands directly at your command line. Again, for Windows users, we do recommend that you add Anaconda to your path environment variable. When you click on it, you'll notice that it says not recommended. It'll highlight in red. Go ahead and click on it anyways, and then hit install. Now, as we previously mentioned, these graphical installation files include Anaconda, Python, and many other libraries in this distribution. So you'll notice that it's actually quite a large file. It's about half a gigabyte. Depending on your internet connection or the space available on your computer, you may not want to actually download and install all these libraries. Instead, you probably just want the basics of Python. For that use case, you can look for conda.io/miniconda-html, or just Google search for miniconda, and it will take you to the miniconda links for the installers. And it's basically the exact same thing, except it's a much smaller file, and it doesn't include a variety of the libraries, which you don't really need to worry about. So there's one for Windows, Mac OS, and Linux. So if you're interested in a much smaller file download, you can use those installers as well. However, we do recommend that if you have the bandwidth and the space, that you just download the full Anaconda installation. Once you've successfully downloaded and gone through the installation steps for Anaconda, you should be able to search your computer for Anaconda Navigator. This is a desktop app that allows you to quickly launch Jupyter Notebooks. So go ahead and confirm your installation by clicking on Anaconda Navigator. It will load up, and eventually you'll see something that looks like this, with little quick dashboards that allow you to launch different development environments. There's the Jupyter Notebook, our main development environment. There's the Qt Console, Spider, another integrated development environment. There's also other things like GlueViz, Jupyter Lab, and even RStudio. If you decide to later on learn R, you can install that as well, with just a click of a button. But we're going to be using the Anaconda Navigator to quickly launch Jupyter Notebooks. So now that we have Anaconda and Python installed on your computer, you should be able to open up the Anaconda Navigator. Up next, we'll discuss how to actually run Python code, either as a script at the command line or using the Jupyter Notebook. Welcome back, everyone. By now, we've learned about the command line basics, and we also have installed Python onto our computer. It's time to actually run our first piece of Python code. Before we do that, I want to discuss the several different ways you can run Python code and the various options there are for developing environments for Python. And there's three main types of environments, and what I mean by environments is the actual thing you're going to be typing Python code into. And the three options are text editors, full IDEs, which stands for Integrated Development Environment, and then there's notebook environments. So let's start off with text editors. Text editors are just general editors for any text file. And that is to say, they're designed in a general format where they can open a .text file, a .py script, a .html file, a .js file for JavaScript, just any variety of file types. You'll be able to open them up and edit them. And they can also be customized with plugins and add-ons. And because of that, and their general format, they actually aren't designed with only Python in mind. So you're going to sacrifice a little bit of Python-specific functionality. Things like autocomplete for Python or looking up things in the documentation automatically for Python. Those typically won't be included directly with the text editor. Instead, you'll have to download them with a plugin or some other add-on for text editors. Keep in mind, there's tons of plugins out there, and Python is such a popular programming language that you can pretty much find any plugin you want already created for you for the text editors you're working with. And the most popular text editors on the market are Sublime Text and Atom, and those are both free. Technically, Sublime Text is an unlimited use free license that you can eventually pay for if you like the product. Atom is an open source text editor from GitHub, which is completely free and it's open source. And later on in this lecture, we'll be showing you how to download Sublime Text and running Python scripts with Sublime Text. So that's one option, the text editor. Another really popular option, especially if you're working at a company, is a full integrated development environment. And these are development environments that are designed specifically for use cases with Python. And they're larger programs. What I mean by larger is that it's a larger file size. The text editors from before, those are actually very lightweight programs that you end up adding more and more to them as you want more plugins. IDEs, they come with everything already, so they have larger programs. And because they're IDEs, it means there's actually a team of developers or a company behind it being paid to add new features to the environments. And because of that, There's typically a pro version and a community version where only the community edition is free, and the pro version that has more features, maybe they'll have more features for Django web frameworks or web development help, those you have to pay for. The community editions are free, however. And the pro about this is that they're designed specifically for Python. They have lots of extra functionality to help with your Python code. But they are a little more bloated, a little larger, and it kind of depends on what your workflow style is, if you like this approach or not. The most popular IDEs for Python are probably PyCharm, that's definitely the biggest one out there, and then Spider is another popular one. Spider is really popular for people coming in from MATLAB into Python. Finally, let's talk about notebook environments. And notebook environments is the environment we're going to be using for the majority of this course. Later on, we'll move away from notebooks and move towards larger scripts. But to start off with, we'll go with the notebooks, and that's because, in my opinion, they're really great for learning. And the main thing here is that you get to see your input code and your output of the code right next to each other, and you get to see multiple inputs and multiple outputs all in one nice notebook. And this is because notebooks use blocks of code that are referred to as cells. So you can split up your code into different cells and then run pieces of your code by running individual cells, and you get to immediately see the output. That's different than the approach taken with a text editor or development environment where you have to develop kind of a larger script first and then run that script at the command line. That's really great when you do have larger pieces of code that need to interact with each other, but when you're just starting off, you kind of want to quickly be able to type something in and see the output, which is why a notebook environment is really great for learning. The other things that differentiate a notebook environment is that they support inline markdown notes. So you can write yourself different pieces of notes. So just normal text is what we mean by markdown notes. And actually the notebooks we provide for this course have a lot of explanatory text for you. So you essentially get a book along with the videos that go with this course. And they also support things like visualizations, images, videos, and a lot more. And because they support all these extra things, they actually have their own special file format that are not a .py script. And because of that, typically if you see a .py script on your computer, you can double click on it and some sort of text editor will automatically open the .py script. Because notebooks are able to support all this extra stuff, they have their own notebook format, which is extension .ipynb, that stood for IPython notebook. And because of that special format, you can't actually double click on a notebook file. You need to launch it using the Jupyter Notebook launcher. So the Jupyter Notebook is pretty much the most popular, and it's almost the only notebook environment for Python because of how popular it is. But it's getting more and more popular, especially in fields of data science and machine learning, because you can see visualizations and your code input right next to the output. So we're going to be using that at first to start learning. But the most important note here is that development environments are actually a very personal choice, and it's really highly dependent on your personal preference. So if Python's not your first language and you're already used to using Sublime Text Editor, or maybe you've already used PyCharm at work and you have the pro version there, and you want to prefer to use those development environments, please feel free to do so. All the code we show is going to work in any development environment that you choose. So really, after you see this lecture, choose whichever development environment you prefer. We provide the notes as .ipynb files, but you can easily convert them or download them as HTML files or .py scripts, and all the code we show in the videos runs the same regardless of what environment you're using. Okay, so let's now explore how to run Python code. We're first going to start with an editor, so we'll download the Sublime Text Editor, and we'll show you how you can create a simple .py script and run the file at your command line. Then we're going to show how to run the same code with a Jupyter Notebook. So to do all this, we first need to download Sublime Text Editor. So go to www.sublimetext.com and we'll see you there. All right, here we are at sublimetext.com, and typically it will auto-detect what operating system you're on, and it will have a little button for you saying download for OS, Linux, or Windows. It's a very simple text editor, and it's probably the most popular text editor in the world. And it has a really interesting pricing scheme. It's technically not free, but they give you an unlimited free trial where they will just have a little pop-up every once in a while asking you if you're ready to upgrade to buy it. So again, it's technically not free, but it has an unlimited free trial for the rest of your life. It will just have a little pop-up asking you to purchase the full license. So click here on download and then select the download for your operating system, either OS X, Windows 64-bit, or Linux. So typically what you should do is just go to the home page and then click whatever download that it auto-detected for you. Once you've downloaded it, we'll go ahead and open the Sublime Text Editor. Once you've downloaded and installed Sublime Text, you should be able to search your computer for Sublime Text, click on it, open it up, and it will look something like this. Next, what we're going to do is actually type out some Python code and then save this as a .py script. Go ahead and type print, open and close parentheses, and then in single quotes or double quotes, hello world. And this will be your first Python script. And then select File, Save As. And the reason we're doing that is if you notice, right now, there's no syntax highlighting. That is to say, everything is the same color for this font. So Sublime Text Editor doesn't actually know that this is a Python script. What we want to do is save it as, and we're going to call this file my example. And you'll notice if you click on all files, you have lots of extensions to choose from. We're going to choose to save it as a Python file. So you're going to say my example, save it as a Python file. The other option you can do is just select all files and then say my example and yourself write .py. Either way is fine. Go ahead and save it, making sure it's a .py file, hit save. And now you'll notice Sublime Text Editor understands that it's a Python script file, and it's performed syntax highlighting to help you read this. Print is a function, hello world is a string. And we're going to be learning a lot more about that and Python in general later on in your training. For now, let's see how to actually run this script. Remember that we've saved it to our desktop, meaning at our command line, we need to change directories to our desktop so we can run this actual .py file. Go ahead and open up your command line. Since I'm on Windows, I will open up a command prompt. If you're on Mac OS or Linux, you'll open up a terminal. Then you'll want to change directory to your actual desktop or wherever you saved this .py file. So type cd and then desktop to change directory to your desktop. And then what you should be able to do is type out Python space, and then begin typing out the name of your file. In my case, it was example.py, and to prove to yourself that we're in the correct location, you should be able to hit tab and it will autocomplete. So here we say Python myexample.py, and this is how you can run a .py script at your command line. Hit enter, and you should be able to see hello world. Now you successfully created a Python script in your text editor, and you ran that script at your command line. What you can also do is just type Python by itself at your command line, hit enter, and this is a very simple direct connection to Python, allowing you to type Python code directly at your command line. We won't really be using this throughout your training because it's only one line at a time, and eventually we'll be using and learning about writing more than one line at a time for code, but you can also just check it out, type print hello, enter, and you'll notice you have hello as the output. So this is basically one line at a time. You can write Python code. Then we can type quit, open and close parentheses, hit enter, and we've quit out of the Python interpreter. All right, so we just learned how to actually run a Python script at your command line. Now let's explore the Jupyter Notebook environment and see how that works. To do so, we'll go to our Anaconda Navigator. So search your computer for Anaconda Navigator, open that up, and then once you've done that, go ahead and launch the Jupyter Notebook. Once you click on that launch button, you should notice that your browser automatically opens up to localhost either 8888 or 8889 or some other series of numbers. Keep in mind that while Jupyter Notebook does operate inside of your browser, it does not require an internet connection. Everything is happening locally. There's no internet connection between Jupyter and some other server somewhere. It just happens to open up and operate in your browser as a convenient graphical interface for you to program in. So once you launch Jupyter Notebook, you'll notice that you can view all the files on your computer. For example, we can click here on the desktop folder, and now I can see that my example.py script we had just created earlier. And using the Jupyter Notebook system, you can actually add on and edit .py files. So for example, we could add on another print statement here, new, and then save this change. So we could say save, and then we could also download or rename the file and a bunch of other stuff. But we're not going to be using Jupyter for this sort of text editing. It's probably better to use Sublime Text Editor, but again, it's personal preference. What we're really going to be using Jupyter for is the notebook system. So you can click here where it says new, and under notebook, you should see Python 3. Sometimes it says conda root or something else, but click on what it says under notebook. Typically it says Python 3. And then you'll notice that we just started a new notebook. So let's have a quick overview of what this actually is. Here it says untitled, and that's because this notebook that we just created doesn't actually have a title. And if we click back here to this other tab, you'll notice we just created an untitled.ipynb file. That stands for IPython notebook file. Jupyter notebooks used to be called IPython notebooks, so they kept the file extension name. And if we want to change this name, all we have to do is go back to this tab, select untitled, and give our notebook a new name. So we will say my first notebook, hit enter, and we've renamed the notebook as well as the actual file. You'll notice now it says my first notebook.ipython notebook extension. So coming back to this notebook, the notebook uses a cell-based system, meaning you write code in a cell, you run the cell, and then see the actual output right below the cell. So let's try running our simple print statement. Inside of a cell, type print, open close parentheses, hello, and you'll notice that Jupyter auto-completes some things for you, such as quotes or parentheses. And then we can run this cell. So you can click here on the run button, and it will run this cell, and you will see the output directly below. This is a great system for people who are just starting to learn about Python because they can quickly iterate and fix mistakes because they have their code and they can see the output directly. They don't have to be constantly going to the command line and running their scripts. Again, it's definitely a personal preference, but this is a nice feature of the notebook for people that are learning Python. And you'll notice that we automatically create another cell below, which you can type more Python code in. For example, print new. And if you don't want to have to click that run button every time, all you have to do is do Shift Enter, and that will run a cell. Again, that's Shift Enter to run a cell. If you just hit Enter by itself, you'll just create more new lines. So it's Shift Enter to run a cell. There's lots of other useful hotkeys where you can click on Help and then hit keyboard shortcuts, and it will list all the keyboard shortcuts. The most useful ones we'll be teaching you later on, but you can always explore that yourself. Now we also discussed that the notebook system can actually hold markdown text. That is just normal text that is not code that you can just use for yourself to type out notes as you're learning throughout this bootcamp. So if you click on a cell, you'll notice here it says code, and that's because this is currently a Python code cell. If you want to make it into just a normal markdown cell, select from this dropdown Markdown, and now this is no longer a code cell, it's just a cell that will just have normal text in it. And you'll notice that it no longer has this in right in front of the cell, so that also indicates that it's just for normal text. So here you can write yourself just notes that will help you understand, and if you do Shift Enter, it will then display them as just a normal text. So again, this is no longer code, it's just text for yourself. And a lot of the notebooks we provide throughout your training will have markdown text as explanation. And if you ever want to write another code cell, you can just hit on a cell and then make sure that it's selected code. And you should be able to print whatever you want here. Shift Enter to run it, and that's the very basics. We'll be talking a lot more about notebooks later on throughout your training, but that's really the basics. The last thing I want to note is that this special extension of the notebook file, this .ipynb, means that you actually can't double click on this file on your computer and expect it to open. So let me show you what I mean by that very quickly. You'll notice that if I come to my desktop, I can see here my example.py, and if I double click on this, it will actually open up in whatever default program I have for it, typically Sublime Text Editor or whatever other editors you have on your computer. So you can double click on .py files, edit them, and work with them. However, if you try double clicking on a .ipynb file, you'll end up getting something asking you how do you want to open this file, or it will just kind of open up and you'll just see a bunch of scrambled code. That means that you can only open these special notebook files through the Jupyter Notebook system. So you'll have to open up Anaconda Navigator, launch a Jupyter Notebook, and then actually find it throughout your computer and click on it. All right, that's the very basics of running Python code. It's time to actually learn Python. Hi everyone, I just wanted to take this lecture to very quickly show you how you can download the course notebooks and open them on your computer in case you're having any issues with that. If you've already been able to do that just from the links from the FAQ lecture or the course overview lecture, feel free to skip this lecture. But basically all I'm going to do here is show you how you can actually download the notes from our GitHub page. So you should have seen a little blue pop-up with a resource link, and that resource link will take you to the GitHub page for Purian Data and the Complete Python 3 Bootcamp. So go to this resource link. You can either type it in manually, Google search it, or just use the little blue pop-up that happened when you were watching this lecture. So let's hop over to that link. Okay, so here we are at that GitHub repository, and this is basically an online repository that you can access in order to get the actual course notes. You'll see here how the course notes are organized. We basically have it numbered off by section, and then inside of these sections you'll see the notebooks themselves, and the notebooks are titled both so that their lecture title matches as best we could with the notebook title, and then we also have them kind of numbered so you can go through them in order. So for example, when you're learning about for loops, you'll go ahead and click here on for loops, and this will eventually load up the notebook. Notice how it's a .ipynb file. But once you have the notebook loaded, you should see lots of useful information here, and then the actual code itself. Now, if you want to run these notebooks onto your computer, what you need to do is download this repository. So we'll come back here, click on Complete Python 3 Bootcamp, and there's different ways you can download this repository. If you're already familiar with Git, you can feel free to fork this repository and then have it on your own GitHub. Keep in mind, we are constantly updating this. But what you can do also to just get the files locally is click here where it says clone or download, and then click on download zip, and that will download a zip file which you can then unzip, and that will have all the .ipynb files that you can then access using your Anaconda Navigator, as we showed in the Running Python Code lecture. All right, that's just a very quick overview of how to get the notes. If you ever have any questions on this, feel free to post the Q&A forums, but definitely check out the FAQ lecture where we have more detailed instructions on how to do all this. Okay, thanks everyone. We'll see you at the next lecture. Hello everyone, and welcome to the Git and GitHub Overview lecture. So in this lecture, we'll just get a quick overview on Git and GitHub in general. So what is Git, G-I-T? Git is a free and open source distributed version control system, and it can handle everything from just a small project to a really large one pretty well. So you can go ahead and go to git-scm.com to learn more about Git, and you can try it in your browser for free by clicking this try Git link on the Git page here, and it'll take you to this link at try.github.io, and it'll teach you Git pretty quickly in your browser. So it's actually a really useful tool. So what kind of companies are using Git, this version control system? Pretty much all major companies such as Google, Facebook, Microsoft, Twitter, LinkedIn, etc. There's a whole list of companies. Many companies use Git. And you might be wondering, what's the difference between Git and GitHub? So GitHub is a web page where you can publish your Git repositories and collaborate with other people. So as I mentioned before, Git's a version control system. So it basically has a series of snapshots of your code, which are known as commits. And as you see the path of the snapshots, you can check what order they're created in. So can you use Git without GitHub is another question people ask. And yes, so Git runs locally if you don't use GitHub. An alternative to GitHub might be using Git with your files and then hosting them on Dropbox. But GitHub is the de facto and most popular streamlined service that's designed especially for Git. So I encourage you to make your own GitHub account and check it out. I have my own GitHub account, and that's where I commit the repositories for the notebooks, and that's how you're able to view them. It's because I'm pushing them to GitHub. If you're interested in working how GitHub works, you can go to guides.github.com/activities/hello world. Again, this link is in the lecture text. and you can check out their Hello World document. It's all in browser, so again, you don't need to download anything. You can just check it out all there. And then another great website for learning Git in general, just Git Git, is gitimmersion.com. And it works for both Mac and Windows. Okay, so that's just a brief overview on Git and version control in general, the links and resources you need to learn more about them. Don't worry if you don't want to check that out right now. Later on in the lecture, we'll touch again on this topic when we talk about modules and importing and creating your own libraries. Alright, that's it for this lecture. Up next, we'll finally get started with Python object and data structure basics. Thanks, and I'll see you at the next lecture. Welcome back, everyone, to this section on Python object and data structure basics. So in this section of the course, we're going to start off by discussing basic data types. And these are your basic building blocks of code when constructing larger pieces of code. And we're going to quickly discuss all the possible data types that we're going to talk about in this section, and then we'll have lectures that go into a lot more detail about each one. So don't worry about memorizing all the information shown here. This is more just a quick overview, and there's going to be a lecture on each of these data types as we go on throughout this section. So the data types that we're going to be discussing are the following in this table. Here we have the name of the data type on that left-hand column, and then there's the type. So what that means is just Python has an internal keyword for this name, and you're not going to get the whole word integer, the whole word floating point. Instead, Python has kind of a shortened keyword. So that's the second column, such as int for integer, str for strings, etc. Then we have the description column, and that's just going to be what the actual description of the data type is. So let's quickly go through these. We start off with integers, and those are just basic whole numbers, such as 3, 300, 200. Then we have floating point numbers, and those are numbers of a decimal point, 2.3, 4.6, 100.0. And notice here that even if you have 100.0, that still counts as a floating point number. That's no longer an integer because it has a decimal point. Then after that, we have strings, and strings are an ordered sequence of characters. You can think of these as just kind of words, but you should also note they can be numbers as well as foreign characters inside of a string. The main thing that denotes a string is that it either has double quotes or single quotes. Here we can see we have hello in double quotes, Sammy in single quotes. We have the digits of 2000 inside double quotes. That makes it a string. It's no longer just an integer because it has double quotes around it. And then you can also see we have some Japanese characters inside double quotes. Then we come to data structures, and data structures are a little more specialized than basic data types and data objects because they can actually hold data objects in some sort of sequence or in some sort of mapping. So here we have lists, and these are an ordered sequence of objects. Here we can see that we've been able to use square brackets and commas to have a sequence of other objects, such as the number 10, the string hello, and then the number 200.3. Dictionaries are another data structure that can store other data types, except in this case, instead of having an ordered sequence, they have unordered key value pairs. And we'll be discussing in a lot more detail how dictionaries work, but here we can see that we have a key, then a colon, and then a value, and it's denoted by curly braces as far as if it's a dictionary instead of just being a normal list, which has square brackets. But then we can have something like name, and then colon, and then the value of that name is Frankie. Again, we'll be discussing dictionaries in a lot more detail. After dictionaries, we have tuples, sometimes they're also called tuples, and these are ordered immutable sequences of objects. They look a lot like lists, except they have parentheses, and they're immutable, meaning you cannot change an object that's already in that sequence. So we'll be discussing what immutable means in a lot more detail when discussing tuples. Then we have sets, which are an unordered collection of unique objects. And again, we'll talk about that in a lot more detail. They're a little similar to a dictionary, but they don't have key value pairs. Instead, they're just unique objects in some unordered collection. So you don't have that colon key value pair. Again, we'll discuss it in more detail later on. Then finally, we'll talk about booleans, which are just logical values indicating true or false. Notice how we have capital T and capital F. That sort of syntax is necessary for Python. So those are all the basic data types. Again, don't worry if you didn't understand any of this or didn't want to memorize any of this. We're going to have a lecture on basically each of these topics in a lot more detail and show you how you can use them to write your own code. Okay, let's get started. I'll see you at the next lecture. Hey everyone, welcome back to this lecture on numbers in Python. We already briefly mentioned that there's two main number types that we're going to be working with throughout the course, and that is integers, which are whole numbers, and floating point numbers, which are numbers of a decimal. We're going to be exploring a little bit of basic math with Python, and then we'll also discuss how to create variables and assign them values. Let's open up a Jupyter Notebook and get started. All right, so before we actually start typing any code, I wanted to briefly mention that if you ever want to toggle this toolbar or this header on or off, you can just come here, click View, and then select Toggle Header or Toggle Toolbar to turn them on or off. And typically, during the lectures, I'll have them off, so we have as much space for coding as possible. Let's start off by just going over some basic math, which is pretty straightforward, and it's basically just using Python as a calculator. If you want to do addition, it's just an addition sign or a plus sign, 2 plus 1. If you want to do subtraction, that's just a dash or a minus sign, 2 minus 1. You can use an asterisk for multiplication, so 2 times 2. And if you want to perform division, that's just a forward slash, so 3 divided by 2 is 1.5. Okay, now let's take a little bit of time to discuss a mathematical operation that you may not have seen before. It's the modulo or mod operator, and basically what this does, it returns back the remainder after a division. For example, if we were to do 7 divided by 4, we get back 1.75. And if you were to do this kind of using elementary school mathematics, you would say 7 divided by 4, 4 goes into 7 one time with a remainder of 3, because 4 plus 3 is 7. Let's imagine you actually just wanted to know that remainder, the actual number 3. In that case, you can use the mod operator, which is a percent sign. So we're going to say 7 mod 4, and it returns back 3. Because 7 divided by 4, it goes in one time evenly with a remainder of 3. So for example, we could do 50 mod 5, and if 5 goes into 50 evenly, then we get back a remainder of 0. Which is nice because it's a way to check if a number is evenly divisible by another number. That's a really convenient check when you want to check if a number is even or not. So let's imagine we have an odd number, 23, and we want to know if it's even or odd. Well, I could just look at it, but maybe sometime in my code, it's disguised as a variable, and I really need to quickly check if it's even or odd. One way I could do this is simply with a mod 2. And I know that if mod 2 results in something other than 0, then we have an odd number. Because if I have an even number, then when you divide it by 2, there should be no remainder, or the remainder should be 0. So that's the mod operator. Again, it just gives you back the remainder after you perform a division. Let's continue with everything else about arithmetic. You can also perform powers, so you can do something like 2 to the power of 3, so that's just 2 asterisk signs in a row. So 2 to the power of 3, that's 8. And then we can also perform order of operations. Let's imagine that I have the following equation. 2 plus 10 multiplied by 10 plus 3. If I run that code, I get back 105. But what if I wanted to actually have 2 plus 10 occur first, then multiply that by the result of 10 plus 3? Right now, we're following basic order of operations with math, which is going to perform this multiplication first before it does this addition. So it's performing 10 times 10, 100, plus 2, plus 3. So to have our operations happen first, the way we want them, we can use parentheses. I can say 2 plus 10 multiplied by, and in parentheses, 10 plus 3. And if I run that, I get back 156 the way I want it. Okay, so that's the basics of arithmetic and using Python as a calculator. Hopefully it was pretty straightforward. Coming up next, we're going to expand on this by showing you how you can perform variable assignments. That is to create your own variable name and then assign an object to it. We'll see you there at the next lecture.